The reason why I just taken a sideline towards discussing about basics of R programming and Python programming, even before we discuss about the visualizations, is because of the reason that unless we develop the visualizations, you will not get a feel of it. In order to develop those visualizations, either in R or Python, it's good to know a bit about it. Okay, the basics, at least the storage types, data types, what kind of various operations you can perform. Okay, and believe me, guys, 60% to 70% of the project time you will be spending on understanding the business problems, collecting the data, and thereby conducting data cleansing, doing the EDA. As part of EDA, the most important work that you're going to do is the pre-processing. Pre-processing with respect to converting the data what you captured from the source into the requisite format where the algorithm that you're going to select, the problem you're going to solve, would be able to leverage the data to give the benefit what you're looking. Pre-processing is most important thing. So I'm going to cover various aspects that you would be doing as part of pre-processing, but that definitely requires a bit of practice as well. And I'm going to showcase you the source of various information that you can refer and practice yourself, right? Even before starting with the basics of R programming and Python programming, let me just bring a bit of comparative analysis so that will be beneficial for you guys to decide which one do you really prefer to stick to, right? Provided if you don't have any programming background, you're purely from non-technical background, could be sales, could be the business analysis, traditional business analysis, could be subject matter experts, could be domain experts who don't have any sort of programming knowledge. For them, I would highly suggest stick to R initially till you get to a level of comfort where you can handle the things from a programming perspective. But if at all you have any sort of programming background, at least if you know the basics, if you have studied C, Java, or anything from your academics, you can start with Python. But what exactly is the main difference between R and Python? And of course, depends on the opportunities that you're going to see. You would need to adapt to that particular tool or software in order to be successful in the work, in the journey of your transformation from a career changing perspective. Needless to say. But at the same time, from learning perspective, let me give you all the insights so that it gives you a kind of comfort in terms of how you can prepare yourself, what sort of practice is required, so that you can switch between the tools. Believe me, guys, once you learn any one of these softwares, and if you're able to perform all the EDA that is required and do the building, do the model buildings, it's not that difficult for you to change or start using the other software. Okay. So to give the basics about the basic idea in terms of the difference between R and Python, where R is purely a function-driven programming language, function-based programming language. And of course, the very strong, huge number of people who are contributing towards the communities who manage these softwares in different areas. We are not just talking about from a programming perspective. We are not a seasoned programmers. If someone asks you, would you be able to program in Python? Straight away say, no, that's not what we are here for. We are here to add value to the business by solving various problems, by analyzing the data. We are not Python programmers. Okay? We are not going to build a web page. We are not going to build a client server application, a web application, establishing the connections to the database to that, so that the dashboards can be displayed. We're not going to perform that level of tasks. There are different set of people. You are purely from a Python developers can take care of that. But using R and Python, what we are going to do is basically add value to the business. Whatever the problems we're going to solve would definitely be saving a lot of cost for the business, where it's very hard to bring that level of interpretation from the other roles that we have been playing for years. Right? R is purely a function-based programming language. Having said that, because of the strong support of the people who are contributing to the respective communities of these softwares, most of the repeated work that generally we spend a lot of time to achieve that repeated task are being made available as part of the packages of the library. Most of the time, we're going to spend time with respect to the analysis rather than building that 100 or 200 lines of code for performing a cleansing process, or kind of building various, carrying out various input process, right? Because of these packages availability, packages or libraries available, so it made our life very easy. At the same time, and most of these packages, or all the packages, goes through a thorough review from the respective community who manages the software. Though the respective code has been submitted by people like us who are working in the area of data science, or machine learning, or artificial intelligence, the code will go through a thorough review. It's not only the objective is not to just deliver the function that is had to deliver, that's ought to deliver. In spite of that, the performance tuning also maintained to an extent where the packages of the libraries that you're going to use would be highly performant, right? We are going to see a lot of such packages in R and libraries in Python, which is going to do that work for us in just a fraction of a second for us. In spite of that, R is a function-based programming language. What do I mean by function-based programming? The moment I load a particular package, I can call that function with a very simple English kind of programming steps. You'll be able to successfully complete the analysis, what you are trying to achieve. That's the whole reason I'm suggesting people from non-technical background to stick to R. But coming to Python, it's an object-oriented programming language, like any other high-level languages, Java, .NET, INX, C#, right? Where you need to follow that hierarchy strictly in order to be able to leverage the benefit of the respective function. And that also we are going to see, right? So let me start with basics of R programming. Once we are done with that, I'll start with basics of Python programming. I would request you guys to open your laptops and do along with me while we discuss, so that you don't get into the basic syntax issues. Okay? Online folks, am I clear?
Clear.
Okay. Effectively, what kind of work we are going to do? Why are we using these softwares? But what aspect of these softwares we need to be familiar? As part of data analysis or data science, we're literally going to extract a huge amount of data from the source based on the kind of the problem what we are solving. And we will analyze that data, bring out various insights, patterns, trends from the data. And we make use of these algorithms, machine learning algorithms, unsupervised learning algorithms, which are far more powerful in terms of identifying those patterns and trends which manually we cannot identify. and thereby that adds some value to the business. Starting with basics of R programming, I would start with the pretty basic step, that the types of the data. From a programming language perspective, how many types of data we have studied so far, or we have been using so far? Integers, floats, string. String means character, okay? Boolean. Boolean means true or false, 1 or 0, okay? So here also we're going to deal with the same types of the data. We're going to declare a variable. Generally in other programming languages, we need to declare a variable, and then we need to assign the relevant data type for that object. Then we start passing in the values to that based on the requirement, right? Here as well, we're going to look at majorly integer, nothing but it still handles the float values as well, which includes the decimals. Hardik, Shamolima, webcam is on. Could you please turn it off, Pristin? Pristin, is webcam is on. Could you please turn it off? Okay. We're going to have integer, which is also handling the decimal values, the floats. And character or string, the data type that will be assigned is character. And we'll have Boolean, which is true or false, and NA values. What are these NA values? Not applicable values, right? So whenever we're extracting data from a source, let it be a database, or let it be the values filled in by business teams manually, or let it be the big data kind of frameworks, Hadoop-based database, HDFS files. It's not always possible for the end users to feed in all the values that are required to save, or all the values that you have to save for a particular record. We always have mandatory values and optional values, right? So you might not get to see all the information present for all the columns. And for some type of transactions, some of the variables would be irrelevant. And this is the reason for you to get the NA values. Or if at all there is some incorrect entry. Okay, and we're going to see how we handle these NA values. Are we clear with the basic data types of the variables? Integer, character, Boolean, right? And then we're going to discuss about the storage types. The storage types are nothing but, as we get to see a lot of information flowing in from the source towards us, and we need to pass in all that information in some format for these softwares to understand. Thereby, it enables us to perform the relevant operation. As part of that, the storage types, what we are going to discuss about is vectors. Vector is nothing but which can have multiple values of the same data type. It cannot have data from multiple data types. Vector is a storage type which allows you to store multiple values of the same data type. So that means you can store all integers as part of a vector. You can store all characters as part of a vector, all booleans as part of a vector, but not a mix of. The next one is list. As opposed to the vectors, List is a combination of values which can be of multiple data types. You can store some integers, some characters, some booleans together as a list. Okay. Then there comes the next most important thing, which is nothing but the data frame. The data frame is nothing but the typical rows and columns structure. Most of the data that we extract, the structured data that we extract from these databases or from various sources would be in the format of rows and columns, right? So you can store them in these softwares, R and Python, as a data frame, so that the relevant operations can be performed. What are those operations that we're going to see in a while? And matrices. We all know what is a matrix. It's also typically rows and columns, but it is of a different type by itself. Because there are a lot of operations, the multiplications, divisions that you apply on the matrices would be different compared to the typical structured data frames. Arrays, what is an array? What is an array? Collection of values, right? Can I have multiple data types within the single array? Cannot. Sorry, should be of the same data type. Okay. Yeah. Okay. Now, after that, when we get into the text mining, dealing with unstructured data, there we're going to discuss about TDMs and DTMs, term document matrix or document term matrix. How do we extract this unstructured data and how do we bring it into a structured format? Thereby, we can analyze from that unstructured data and build some interpretations, right? This is a typical, the basic funda on which these softwares work, the data type and the storage types. The syntaxes would differ of performing a certain activity in R versus performing the same activity in Python, right? Now, let's get started with the basics of R programming. Now, when you open the software, R software, you will have 4 panes that are displaying as you are seeing there. The left top pane window, what you are seeing here, is called as programming window. And this is where scripting window. This is where we develop our scripts. Right? Let it be a function, let it be a code, or let it be a model that you are building, or let it be a visualization. Everything you will be scripting in this particular window. And the left bottom one, what you are seeing here, will show the results of what you execute here. Whatever the scripting window, whatever you are executing, the left bottom one will show the results of it. And the right side top window is the environment window, where you can see all the variables that you declare, all the functions we execute, right? And the right side bottom window that you are seeing here is nothing but a visualization. You can see the plots, you can see all the packages that you have already loaded into your session. Am I clear? Now, if I would like to store the values from 1 to 20 into a variable in other languages like .NET, Java, could be anything. How many lines of code literally we need to write? So typically 4 to 5 lines. First we declare a variable, then we assign a data type to it. Then we pass in the values what we would like to, in an incremental fashion or whatever, if it is a series, right? But here, guys, is it visible towards the last? Do you want me to increase the font? Is it better now? To assign the values from 1 to 20 to a variable, here we just need to write this line of code in R. By the way, this less than and hyphen, what you are seeing here, is an assignment operator, like is equal to. You can still use is equal to in R as well. But the reason why we are using less than hyphen instead of is equal to is because of the performance reasons. And it's highly suggested to stick to this syntax. Okay. So I'm just executing this line of code. To execute a line within a script in the debug mode, you can run it in multiple ways. You can just place the cursor anywhere on that line and just say Control Enter. Or you can just select that line and say Run on the window. Right? There are different ways to run a line of script. Now, when I executed this, if you observe in the environment section, you're seeing here, right? The variable A has been created. And it's been assigned a default data type as integer, int. We don't need to declare anything. R and Python are intelligent enough in terms of understanding what type of the data that you have. But sometimes when your data is too clumsy or when your data is too misleading, even the softwares also get confused. They would assign different data types. In that case, you need to change the data type of the object or variable, then perform the relevant operations. Right? You see here, this object A has been created. It's been assigned the data type of integer. And the values 1 to 20 have been assigned to that variable in a sequence. To define or to send a sequence of numbers, you need to use this colon 1 colon 20. Right? Now, if you'd like to see what values have been assigned to A, you can just select A from the line 9, say Control Enter, or you just do it in a separate line. Now in the console window, you will see the output of it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 till 20. Clear, guys? Might be it is minimized, just maximize it in the bottom. You're not getting that console window. Just a second, guys. Yes, when you install for the first time, you will not have the scripting window opened at all. Only the console window would have been maximized for you. In that case, you need to go to File, say New File, and do R script. That means we are opening a new scripting window. Okay. So whatever the code I'm showing you here, you need to write it in the scripting window. And thereby the results can be seen in the console window. Right? Fine. Now, to check the data type of a variable or an object, the function is class of A. Class within the parenthesis, you need to pass in the variable for which you'd like to see the data type. Just say class of A. I'm going to say that integer. Now, to get the count of the values that you have in an object, a variable, number of value you have stored in a variable, the function is length of A. Very important. We get to use many times this particular function. Length of A. We have passed in the values from 1 to 20. That gives the output as 20. Length of A. Right? Now, I'm creating a new variable called B. But this time, I don't want to store or assign the values in a series. But I'd like to pass in the values randomly. 4, 7, 3, 5, 6, 1. Any value, any random value of your choice. Okay? But the syntax to pass in the values to a variable is these values needs to be passed in through a function called cof. Here C is for concatenate or combine. Now we are just combining all these values. Yeah, and assigning to a particular variable. And the cof, which is combine or concatenate, is also widely used function. Right? Now I assign these values to B. And see what all the values assigned to B. 4, 7, 3, 5, 6, 1. In class of B, what do you think would be the data type that is assigned to B by R by default? This is numeric. The difference between integer and numeric, integer can hold the whole numbers. Numeric can have the new digits as well. Float values. This is like for float, the data type float. Because we are not sending, though we have assigned all the whole numbers, because they are not in a series or a sequence. And R by default understands that it as a numerical type of data. So far, we have passed in the integers or the numeric values and saved them into the variables, stored them into the variable. Now, to pass in the characters, these characters needs to be associated in double quotes. No, integers cannot be decimals. Only numeric data type will hold the decimal values. And that's how it's been defined in R. Okay. Shilpi, are you clear? Okay. Now to pass in the characters, these characters needs to be surrounded with the double quotes or quotes, single quotes. Again, I'm using this combine function. So whenever you're using a function, immediately after the function, you will open the parentheses in R. Okay. To see what all the values have been stored. Execute the variable. And what should be the character class of gel? Yeah, it is character in R. Okay. It's character data type. Clear, guys? Now I'm passing the combination of a character and an integer into a variable. What do you think would be the data type of that combination of character and integers? If I store them together, what would be the data type assigned to that? Sorry, it should be character, right? It will be defined as a character. It will be assigned the character data type. The reason being, though you have integers, if you give integer data type assigned to that, but still if you attempt to perform the relevant operations on the integers like additions, subtractions, multiplications, you cannot apply on this. That's the reason the entire data will be assigned the data type of character. Clear, guys, so far? Now I'm passing in 3 sets of data. One is integers, characters, and Boolean. What would be the type of C now? Character. Character takes the highest precedence. Now I'm declaring another new variable which is D, and I'm passing in 3 sets of data. Now what should be the data type of it? D. 3.4, 5.6 are part of the first set, which are numeric. 1 to 20 are integers. A comma B are character. Right? Now let me show you what all the values I have stored in all these 4 objects. A. In A, we have 1 to 20. In B, I have some random values. C, I have the combination of characters, Boolean, and integers. D, we have just seen, right? Now, if I say A of 4, 4 is mentioned, or 4 is written inside of square brackets. What do you think will give the, what do you think the result will be? 4. Why? So we are, A of 4 means we are trying to extract a value based on the location within the set of data. Right? The values what we have in A is from 1 to 20. In 4th location, we have the number called 4. And that 4 will be returned as an output. But whatever we are mentioning here within this square bracket is the position or the indexing. Index-based extraction. Clear? What do we have in D? So these are the values which are stored as a character in D. So what do you think this line of code, which is 45, will give me? (19 to 23), not 24. Why? Yeah. In 19th position, we have 17, 20th, 21st, 22nd, 23rd, 24th. 19 till 24. So by now, you must have been understood. So what is the starting point of indexing in R? It starts with 1. Okay. Either that could be the row numbers, it could be the column numbers, anything. The indexing starts with 1 in R. Whereas in Python, the indexing starts with 0. Okay, that's a difference you need to be aware of. So now what do I have in C? I have 2, 3, A, B, true and false. What do you think this line of code gives me? 46. What is the first C? What is the second C? Exactly. The first C is a variable because after C you are seeing the square brackets. Second C is a function, C of. After second C you are seeing the braces, right? Concatenation of 3, 4, 6 means I would like to extract the values from variable C, which are there in the positions 3rd, 4th, and 6th. Now tell me what are the values that we have in the 3rd, 4th, and 6th positions? A, B, and false, right? Clear? Just do the control enter to execute the line. Click on the run button by selecting that part of the code. Now, what do you think this will give me? 47. B of -2. Let me show you what do I have in B. Now tell me, What B of minus 2 will give me? Okay. It's different languages work in different way, right? So in R, B of minus 2 will exclude the value that we have in the second position and will return all other values. Because sometimes we don't need few values. For that, we don't need to actually select all the values that we want. Just by excluding those that we don't want, we will be able to extract that whole number of values. Right? Now B of 2, what it will give? Which we have 7, right? Second. Clear? Now what is B of minus C of 3 comma 5 gives me? It's pretty straightforward language. We don't need to trick too much. Okay. We are where that minus sign is. We already seen whenever we are applying minus, we are trying to eliminate that, or we are trying to exclude that value which is there in that position. Now, is this minus is only for third position or is it for fifth position as well? For both, because we are using this concatenation function. Okay. It excludes third value and fifth value. It returns all other values. Okay. Yeah, you are right, Shilpi. Now, let's make it a little more interesting. What do I have in A? 1 to 20, right? So far, inside these square brackets, we have been mentioning the position or the index number. Now, I'm mentioning A percentile 2 double equal to 0. What do you think this will give me? This entire line, 54. Gives only the even number. Exactly. Because whatever we are mentioning within that square brackets, we are passing in the index values. We all know that the expression which is there inside of the square brackets, what would be the result of this inside part which is there in the square brackets? A percentile 2 double equal to 0. What would be the result of it? See, I'm not passing in a single equal to here. I'm passing in a double equal to. That's a comparison operator. Is equal to, is not equal to, right? So it takes all the values in A, it divides with 2. What does this percentile does? This A percentile 2 is nothing but the remainder. You're going to compare the remainder, whether the remainder of A, that value, is equal to 0 or not. So what would be the result of this? And execute only this part. True, false, right? What is the first value in A? We have 1, right? If I divide 1 with 2, is the remainder is going to be 0? No, right? So 1 is odd number. Only for even numbers, we can have the remainder as 0. So for all odd numbers, it gives false. For all true even numbers, it gives as true. Right? Now, I'm passing this within the square brackets for A. So wherever true is there, I have this true in all even positions. All values that are present in the even positions will be returned. Right? Effectively, even numbers will be returned. Because our values that we stored in A are nothing but 1 to 20 in a series. Clear? Now tell me, what should be the result of 55? Line number 55. This one. All odd numbers. Right? Now I'm updating B. I'm redefining B, sending different values. What do you think this will give me? Multiples of 6. But what would be the result of it? Because I have only 6, right? 12 is there. Yeah, this will be applied on this data only. Out of all these values, which one, if I divide that with 6, will give a remainder of 0? Only 6, right? Okay. Now, so far, we have dealt with vectors. We have passed in a single value into an object, except that C and D. In C and D, we have a combination of integers, booleans, right? So whatever the values, that if you look at this B, I'm passing all the values which are of the same data type. Clear? Now, I'm creating a new variable with multiple vectors in it. But within that, for each set, I'm passing in a name to it, right? It's a combination of integers, boolean, and numerical. Now, if I see how it displays, indexing will add next to the name that we supplied. We have 4 values supplied under R. So it's like title, other name for that variable. R1, R2, R3, R4. After that, F1, F2, F3, F4, F5. Clear? What do you think would be the data type of this? E? Sorry? Character. Yeah, if you see here, all the values have already been converted to decimals. Clear? I'm passing in 3 values to the variable j, passing in another 3 variables to the variable k. Can I add these 2 objects of the variables j and k? Can I add them? J plus k. Now I have 4 values in x and 3 values in y. Now can I add it? Sorry. Okay, that's one assumption. What is the last value? No. 1 plus 4 is 5. Next, 2 plus 5 is 7. Next, 3 plus 5 is 3 plus 6 is 9. Next, how did we get this 8? Exactly. It starts looping in. So here in x we have 4 values. In y we have 3 values. But here we are trying to add 2 vectors which are of different sizes. Hence, it again loops in right from starting. The indexing will be 1, 2, 3. And again for 4, it lets reassign as 4. So 4 plus 4, 8 it has been. And if you look at the error here, sorry, the warning, longer object length is not a multiple of shorter object length. Can I do x minus y? Why can't? When we are able to perform addition, we should be able to perform the subtraction as well, right? Can I multiply? Division? I'd like to increase or multiply every value of that variable by 3 into 3. Clear, friends? So far? Online folks, any doubts, any questions? Give me a minute, friends. I'll get some water. Okay. Now, I'm creating a new variable called LL. Passing in different values randomly using the function combine, C of. What is this max of LL gives me? Maximum value, what is that? 12. 78, right? Maximum value. Now, which dot max? Exactly. Okay, which dot max gives the index of that value. The max value is 78. What is the index of it? Indexing starts with 1, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Which dot max? Now, LL of which dot max of LL? What does that give? LL of 10, right? What is it? 78. Clear? Similarly, which dot min? So what is which dot min of B? Which dot min? Min of B is 2. Which dot min? 4. Fourth position of it. Next, right? And what is the switch of B percentile 2 double equal to 0? What does it give? How many are you from programming background, friends? Think should. When in academics nowadays, unless and until you practice, you will not pass the practicals, right? Okay. Which of B percentile 2 double equal to 0? What does it give? It gives the positions of all the even values in that, right? Clear? So what is this? B of B percentile 2 double equal to 0. Whereas earlier it was giving the positions, index. But here it gives the values. Yeah. What does 1 or 2 line gives me? Do I need to increase the font further, friends? Not needed. What does it give? Let me show you what I have in B. Now tell me what are the values I'll get. 6, 3, and 33. Are you sure? And ampersand is for and. Yeah. Only we should get 33, right? Now this pipe symbol is for R. What does it give? 6, 6, 3, 45, and 33. Isn't it? Right? Now, we already seen measures of central tendency. What do I have in A? 1 to 20 I have. To get the average or mean, the function is mean. Mean of A. Clear? This is B. Now tell me what is the median of B?
Sorry, I have a small question.
Hmm.
So basically on row number 104, for example, right? So we are putting it in within a square bracket.
Hmm.
So doesn't it mean that for that index, we have to provide the value? Or we have to just provide the value?
No. See, this is a variable in which we have the values, B. And within the square brackets, if you know the index already, you can straight away provide. But as we deal with a huge data sets, it will be very difficult for us to pass the positions of those values. So here we are going by criteria base. So whichever the values that are located based on this criteria, I would need to get all the values. That's the whole idea here. Am I clear?
No. So basically my question is that within the square bracket, generally we provide the index. So for example, this is my criteria. So with this criteria, I'm going to get a value of 33, for example. Now, if I get 33, so does it mean that the value at a 33rd position should be the value output, or?
No. Based on whatever we have within the square brackets, we get the position. If I just execute this, just give me a second, friends. Just give me. So if I just execute this part, which is there within the square brackets, do I get the value or do I get the position? It's a comparison, right? True and false. Wherever the true is there, only those values will be given when we associate that with this overall. So out of all these values, whichever is true. So for the second value 6, that is true. So it is going to give the output. It is going to include 6 in the output. Next 3, next 45, next 33. Am I clear now? Still there is some question.
Yeah, fine.
Okay. Now this is B. So what will be the median of B? Sure. How did you calculate the median? middlemost value. So which one you are saying is the median? Because the middlemost values are 2 and 3. You're taking an average of it and saying that 2.5. Is that right? You need to sort the values, right? We need to sort the values. Once you sort it, 6 and 7 will be in those two positions. So take the average of those two, it will become 6 points. Now what is the mode of A? In A, I have values from 1 to 20. What is mode? Most of the times, right? So any one which is any value which is repeating for more than once in A. All right, it's purely from 1 to 20. Now, passing in random values like this and storing them in the variable Z. Now tell me what is the mode of this? Should be 3 because it has repeated for 3 times, the highest number of times. 5 how many times? 2 times. 3 is 3 times. There is no inbuilt function called mode. That's the reason it is given. So if you'd like to calculate mode, you need to write custom function in R. Okay. I'm going to show you how to write custom functions. What do I have in D? We have 24 values, right? Now what is the length of D? Should be 24, right? Length gives the number of values. What should be the class of D? Character. What should be the mean of D? Average. Because we have characters, right? How can you calculate for the character? Mean cannot be applied. Argument is not numeric or logic. Returning NA, null, not applicable. Now, to look at D, except this A and B, remaining all are numeric values, the integer or numeric decimals or anything. Right? So, what this part will give me? D of minus C of 23 and 24. It excludes A and B and gives all other values which are there in D. Right? And since we cannot perform the arithmetic related operations on the entire variable, that is D, I'm now converting that by removing these two values into integer. To convert the data type of a variable, the syntax is as.integer. This is a new variable I'm creating. I'm not updating existing. Okay. As.integer, as.numeric, as.character, as.boolean are the syntax for you to convert data type of a variable. Now, if you see what is the data type of temp, that will be integer.
Just a small query here.
Yeah.
So can we also, what is the reason? Can we also directly do this for temp? Can we directly assign a new variable? Just using this function minus C 23, 24, because if we just remove 23 and 24, it becomes integer already, right? So can we do it directly also, or as dot integer function, we do need to call that?
No, the reason being the original data type are assigned to the D is character. Though you remove A and B, the data type wouldn't change.
Okay, understood.
Yeah. Since this is a small data set, I know what is the position. But generally, we go with the criteria-based selection. Okay. Criteria-based in the sense, here we had seen, right? Yeah, it's purely condition-based. So let's say if you're dealing with temperatures from different cities, whichever the city's temperature is more than 34, update that with this value. Purely criteria-based. Now we can apply the arithmetic related operations on this, since it is an integer. Mean, yeah. To convert the data type, the syntax is as dot integer. Now, what do you think this will give me? Is dot integer of D. True or false, right? Is dot integer. And that's why I told in the beginning of this session, it's pretty much English-like language. I have 1 to 20 in A. Is dot integer of A. What should be the result? It should be true for all 20, right? A is a variable which is having all the integers. The data type is integer. It should be true. Length of D, 24 values we have, including A and B. Is dot numeric of D, false, because it is dot character of D, should be true. Okay. Now, to sum the values, simple function, sum of, max of, min of. Okay. You don't need to load any packages for these basic operations, right? I'd like to assign the values in the reverse order. The syntax is same as earlier what we had seen, but this time we need to mention that maximum value colon minimum value 20 colon 1. Clear? Which dot max we already seen. Now let me show you how to write the custom function. Let us calculate the mean of a set of values that are passed into a variable, right? For that, the syntax is, you can define any name of your wish, store that function. I'm assigning, and this is the overall function body. It should start with a keyword called function of x, then, and this is the actual body of your function, where it starts with a curly braces, ends with a curly braces. And between this, you simply write the lines based on what you are trying to achieve. To calculate the mean, first we need to take the sum of it, right? Calculating the sum of x and assigning it to a variable called sum. And make sure, don't ever use the same naming conventions for declaring a variable or a name which matches with an inbuilt function. Okay. And for calculating the mean, I'm doing sum divided by length of x. Can I do this? Length of x gives me number of values. Sum divided by number of values. It gives me mean, right? Once I have the mean, I'm printing it. Right? And this is a custom function, simple custom function we have written to calculate the mean. How do you execute the function? What this function will return? Which language you are working? Okay. No, what would be the result of this function? Function doesn't give any result. It just executes. When you apply this function on a data set, that's when it gives the result. Okay. So for executing these functions, you need to select all the lines of that code and then execute together. Now, what do I have in A? I have the values from 1 to 20. Now I would like to understand or calculate the mean of the values in A by using the function we have written. So the name which we have assigned to this function is mean underscore fun. So I'm saying mean underscore fun of A. With 10.5. Clear? Is that, did you pass in the correct name? Hmm. Is the same name where you saved your function? The second, friends, online folks, just give me a second. Hey guys. So now let us see various operations that we can perform on lists. How list as a storage type works, and how do we extract the values from list, and what kind of operations we can perform on a list. As part of vector, you can save the data of same type, but as part of list, you can save a combination of values of different data types, right? So I'm creating a list. We're passing in different values like this in different sets. 22 false, ABC, and decimal values. Now, what would be the class of P underscore 1? List. Sure. To convert that as a list while defining itself, you need to say that as a list, like the next line. So now it becomes a list. If you see in the environment window, now the P, variable P has been created as a type of list of 4. What is this for? Yeah, it is having 4 list items. In each item, in each list item, further can have multiple values. Clear? Now, am I audible, friends? Okay, fine. What should be the class of P? Should be list. What is the length of P? Should be 4 items, right? Now, it's very important to understand how do we extract the values which are part of a list. Now, what do you think this P of 1 will give me? 1 to 20. Right? What is this P of 1 in double square brackets will give me? It gives 20. Okay. But let it be a single square bracket or double square brackets. We're just passing in the list item number. It gives the complete values of that particular list item. But to extract the internal values of a list item, you need to extend this another square bracket. Okay. First, I'm extracting all 20 values, 1 to 20, which are part of my first list item. In that, which value I want? 10th. So I should get the output as 10. Clear? What should be the class of P of 1? It cannot be integer. Even the list items will also be the data type of list. Okay. Class of P of double square brackets 1. Now it is indeed. Okay. So if you are referring a list item within double square brackets, you can straight away start performing the relevant operations on that. Means P of 1 being in the double square bracket is of type integer. So integers, what all operations we can perform? Addition, subtraction, multiplication, divisions, anything, right? Sorry. All the values within first list item are being multiplied with 3. But the same thing we cannot perform on a list item. P of 1, which is in a single square bracket, is still treated as a list type. Non-numeric argument binary operator. It has thrown an error. We cannot perform that operation on a list item, right? Which one? Which one? Last part of it. Okay. What is the class of P of 1 being in double square brackets? What is the class of it? Is it an integer or list? Being in double square bracket, integer. Because the data type is integer, you can straight away perform relevant operations like addition, subtraction, multiplication. That's why it has straight away multiplied all the values in first list item with 3 and shown the result. But what is the class of P of 1 being in single square bracket? List, right? So I want to multiply values of a list item with 3. Can I perform? That's what is going there. Okay. Now, what is this P of 2 of 2 will give me? Let me just show you guys what I have in P. True and false I have. P of 2 of 2 will give me false. Right? 3 of 2. 3 I have A, B, C, B. 4 of C of 3, 4. Third and fourth. P of 4 is nothing but fourth list item. In that third and fourth. Right? Clear? Now, I'm creating a new list item. I'm appending a new item to the same list. Saying P of 5, passing in the values. Now, if I see what is there in P, I have 5 list items, right? List separated by comma. I didn't get your question, Shilpi. Can you come again? You can unmute yourself, for example, 1 comma 2 comma. No, if you have the values which are part of the list, it will be shown in this order. Okay, list item 1, what all the values you have. List item 2, what are the values? 3, what are the values?
Yeah, I mean, just to have a more readable, for example, this 4.5, 7.8, it's not that readable. So if I want to make it readable and put 4.5, comma 7.8, comma 2.0,
Okay.
and so on.
Yeah, if you just put across comma, you will not be able to execute that command. That's not the syntax it supports.
Okay.
Okay. Okay, so now I added a 5th item to the same list. But I'm resetting the first list item to null. Now, if I open P, what do you think the indexing would remain the same for all the list items? Because the first list item has been set to null, automatically the indexing will get upgraded for the remaining list items. Originally, I have 5 list items. The first one has been set to null. So the 5th one, which I added, the index has been upgraded to 4 because first one doesn't exist. Okay. Clear? Let's take a break and come back. We'll continue the discussion. Let's come back by 4. Yeah. Online folks. We'll come back by 4 o'clock. We'll resume the session. Okay, this is how we create the list by providing the names. Just give me a second. So we can create the list by providing the name to the list items. Now, if you see what is there, instead of the list index number, been referred with the name, right? Now, Q of A within quotes in double square brackets, what do you think it will give? 3, 4, 6. Yes. The same thing can also be referred as Q $A. Typically, this is how we refer when we load a data frame, right? When we load a data set into R. To refer a column name, this is how we refer. The variable into which the data frame is set, $, the column name. Okay. To create a new list item, and what would be the data type of list item A? List or integer? Integer. Depends on the values. If you have provide the series of values or sequence of values, by define R assigns that as an integer. If it is random values, then R assigns that as numeric, right? To extract the second item from the list item A, we have 3, 4, 6, right? So this gives me 4. These are all something we already seen. There's a function called view. What do I have in A? 1 to 20, the row format. If I say view of A, it opens up a new window, but it shows that in the column format. Okay. Are you feeling there's too much of programming? Right, it's basics, right? Just need to practice, that's it. You'll be fine. So you're going through this for the first time. I'm just introducing you different syntaxes for performing different operations. In Q, what do I have in Q? I have 5 list items, right? Initially, I created 3 and assigned the names for the list items A, B, C. And I created a new list item with the index 5. The 4th one has been left null. Okay. The same thing if I say view, it will be in a row and column format. No. If the values are already there in a series, and if you set one of them which is there in the middle as null, it automatically rearranges the index, which is the first instance we had seen. But here, intentionally, we want to create a set of values as a list item of index 5. What R thinks is, we are going to do something else with the index 4. We want to save another set of values. That is the reason it is set intentionally at 5 itself. Okay. So here, the queue, the names of the list items A, B, C. If the name is not given, it will be referred with the list item number within the double square brackets. And the second column is the type of it: list, double, logical, double, null, integer, and the value of it. How many values are there? What values are there? Okay. Now, A is a vector of all the integers. Q is a list item of 5 list items. I'm combining these two using the function concatenate. So that means that does not stay saved as a list items. No. What I'm saying is, the other list items, which are B, C, 4, and 5, are not separated, right? In your case. Can you see the class of B or C? Then you will understand where you have gone wrong. So now I combine both A and Q. A is a vector, Q is a list. Just see what is there in J. The first 20 items which have been there in A have been created as separate list items. The first 20 list items would be, sorry, first 20 will be the first 20 integers will be created as separate list items. After that, your A will become 21st index or list item. So from there, you will have Q items. Clear? What does this give? Which dot max of A? What do we have in A? 20. Dot max of A? With 20, right? Which gives the location or the index. Which dot max of Q? What do I have in Q? Five list items. Which dot max of Q? Five. Come again. 9. Okay. Which dot max of Q? Can you apply arithmetic operations on a list? No, right? That's error. And if you already have a list, you can split that. Means you can unlist it. Q is already a list. If I apply the function unlist, let us see how it works. Now, if I want to see all the values, they'll be in a typical row format. But all the Boolean values will be represented with 1.0 or 0.0. Okay. Since the names were already there for the first three lists, they have been referred with the respective indexes. A fourth one is a null, hence it has been removed. Fifth one, we have 4, 5, but there is no name to it. That's why it is shown as 4.0 and 5.0. Clear? Now, what should be the class of F? Numeric? Because they're all decimals, right? Clear? Now, we're going to look at a couple of very important functions which you are going to use maybe in your day-to-day life when you get into the data science. These functions are sapply and lapply. Sapply is basically for applying a function or a custom function or an inbuilt function, whichever, or any operation or any expression that you build on a huge data frame, a list of values. This basically sapply returns the vector. On a vector, we generally apply this sapply function. But whereas on a list, we use lapply function. Now let us see what is the difference between these two. In Q, I have 5 list items, wherein the fourth list item is null. I'm passing A and B for the fourth list item. Can I apply mean on this Q of 1 in the double square brackets? Can we apply mean function? What do I have in Q of 1? Nothing but, can I apply mean on that? We can apply only and only if this 1 is mentioned in the double square brackets. Right? Now, the same thing I'm applying using sapply. I'm applying it for the entire list, that is Q, comma, the function which I'm applying, the inbuilt function mean. With a simple line of code, I'm applying this mean on each and every list item. Right? But if you see here, for the fourth list item, it has given NA. Why do you think it has given NA as a result? So we just passed in A and B for fourth, right? Because they are characters. We cannot apply mean function on characters, right? That's the reason it has written as NA. But in B, I have true, true, false. But still, this sapply has returned a mean value for that. What it does is, it converts 2 as 1.0 and false as 0.0. Out of all three values, you have 2 as 1, right? Sum of it is 2 divided by 3. 2 by 3, how much? 0.667. Clear? Okay. When I say double square, though it is a list item, the data type of that particular first list item will be read with respect to the values what you have. In Q of 1, we have 3, 4, 6 values. Ideally speaking, it should be an integer or numeric. When you are using double quotes, it automatically considers that as an integer, a numeric, and applies this function. But if we remove, if you just apply in single quotes, single square brackets, then you will not be able to apply these arithmetic operations because it treats that as a list item. Okay. And similarly, we have A, where in A we have 1 to 20 values. And to apply square root function on each and every value of A, you can make use of sapply. Sapply, data, the object in which you have the data stored, comma, the function. This sqrt is the inbuilt function for applying square roots. Right? Now, let's say if I apply lapply for the same square root, it returns the results as a list. Whereas in case of sapply, it returns the values in a vector format. Whereas by using lapply, it returns the values in a list format, one after the other. Each item will be treated as a separate list item. Each value will be treated as a separate list item. Am I clear? Online folks, any doubts so far? No, we are not at reach to the data frames, Vani. We are still discussing about sapply and lapply, but effectively, we end up in using these sapply and lapply on the data frames. As long as you are dealing with structured data, right? Okay, now I'm creating another list with three different items, A, B, C. You see G, first I have some random numbers, 3, 45, and 6. In second list item, I have characters. Third list item, I have numerics, decimals. Now, can I apply the sum function on all these list items? Who's there? But can I apply sum function on only the list items A and C? What are A and C? A is numbers, C is also numbers, right? Clear? Now, I'm creating another list with 4 items. Now, can I apply sum function by using sapply? Can we use it? This time, it gives the results wherever it is relevant. In case of B, all the characters are there, right? Yeah, all the characters are. In C, I have Boolean, where applying sum doesn't make any sense on these 2 list items. That's how it understands. That's how the software is built. Oh, this 1,4. Okay, fine. Sorry for that. I thought it's full. Can I do this now? You already seen, right? In the previous. Close the arrow. That means we need to be aware of what kind of functions we can apply and what kind of data. It's not only the variable type is important, but also the storage type is also important. And if you apply, I'll apply the same first and fourth. It returns the results as list 6,233. Whereas sapply gives that as a vector. Okay. What do you think this will give me? We should always read from right to left, not from left to right. The leftmost function will be applied at the last. Same thing, whatever we have done here. First, we are applying that. As a result of this, what would be the result of this? Is it a vector or list? This highlighted part. lapply. Yeah, lapply gives the list as an output. sapply gives the vector output. I'm getting a list. I'm unlisting it. The moment I unlist it, shows as good as a sapply. Clear? Like a vector. Now, Let's look at the data frames. The data frames are typically rows and columns format, but most of the times we get to deal with. To define a data frame, the keyword that we need to use in R is data.frame. I'm creating two set of values. One is integers, the other one is characters. I'm creating a data frame with it and assigning that to a variable called capital A. Why do you think it is not created? The length should be the same. In the first set, I have 3 values. Second set, I have only 2 values. So it doesn't allow to create uneven length of sets. Because that's a rows and columns format, right? You should have values for all the, right? But whereas, if I increase the length of second set also to 3, now it's created. Now, if you see in the environment section under data, the variable A, capital A has been created with 3 observations and 2 variables. What are the observations and what are the variables here? Let me just show you what is there in A. So observations are nothing but the rows, right? And variables are nothing but the column names. Since we didn't provide any column name, by default it has assigned these column names. C to refer the column with the values that you have in that column. Same time, if I say view of A, it opens in a new window in a more structured form. You can update the names of the columns to reflect correctly. Just give me a sec, thanks. Now, I would like to update the column names of this data frame. What I'm doing is data.frame of ID equal to the first set, names equal to the second set. Now, if you see here, the column names have been updated. ID and names. To get the column names, what all there in a data set that you load in a data frame, the syntax is call names, COL names. Friends, R is a case sensitive. Python is also case sensitive. So you should follow the exact syntax. Call names of capital A. It gives the column names. We have 2 columns. First one is ID, second one is names, right? Now, I want to update the same column names to some other names. I'm not satisfied with that. So syntax is call names of A as C of provide the new names. A lot of times we get to update the column names because most of the times we get to see some chunk ones, or sometimes we don't have column names at all, right? And view of A. Those new column names have been updated. Clear? Now, DAM of A. DAM is the function, inbuilt function that is available in R to get the dimensions of a data frame. What do I mean by dimensions? What are dimensions? Rows and columns, number of rows and number of columns, right? Get the sizing of it. 3 rows and 2 columns, 3, 3. Okay. Now, I'd like to extract all the values of the first column, which are there in ID. Is it ID or college ID? ID is already changed, right? That's why we get null. College ID. Variable into which the data frame is saved, $, the column name, extracts all the values. Now tell me, what is this A of 1 gives me? You know what is this A? A is 3 rows and 2 columns. What is this A of 1 gives me? 1A means first row, you are saying. Okay. Any other thoughts? One, 4, 5. Right? So that means effectively we are referring the column name, column index. Indexing starts with 0, right? Sorry, 1, R. So the first column is nothing but the college ID column. If you don't provide any other syntax, just provide a simple number that becomes your column index. You have to use the second column, name of student. Now you tell me, what do I get from A of 1, 2? What is there in A? First, whenever you are mentioning this comma within the square brackets, there's nothing but the syntax is rows, comma, columns. That means first row, second column. A should be the result. Right? And also, if you see here, it is saying levels equal to A, B, C. Column index. If you have two values that are separated with a comma, that treats that as a row, comma, column. Okay. But if you see here, the levels are also mentioned, A, B, C. What do you think these levels are? Now I have two columns. One is college ID, the second one is name of the student. Can you tell me the data type of these two columns? What is the data type of college ID? No, I'm not talking about programming level data types. I'm talking about whether it is continuous or discrete. College ID is also discrete. And how about the name of the student? Is categorical, multiple categories, multiple names you have, right? But because of the data, because of the values what we have in the first column, R doesn't think that it is a, just give me a 1 second. Now I executed A of 2 comma 1. 2 comma 1 means second row and first column, that is 4. Here it is not giving that levels. But when I execute this A of 1 comma 2, that means first row and second column, it has returned me A, but in addition to that, it is giving me levels. Because of the type of the data are things, only this as the categorical data, not the first column. Categorical data means you will not have no middle values. You can have either A, B, C, that's it. Right? Clear, friends? Column names. So just seen, right? Call names of A is equal to C of, provide the new column name. What do you want? Yeah. Call names of A of which column you want? How do you refer a column with an index? Like this, right? A of the respective index of the column which you want to change and provide the name. That's it. Now, by default, there are some packages that will be installed with your base installation in R. But just say data off. So there are some data sets as well that will be installed along with the packages that are installed with the base install. So these are all the data sets that are already available, which you can practice with. Out of this, now I'll show you with one of the data sets. I'm picking a data set called empty cars. About any data set you want more details, just say question mark empty cars. If you say question mark empty cars, the complete documentation will be open for that in this plot window. Complete details about that data set. What is the description? What is the format? What all the columns are there? There is operation that you can perform on that. Yeah. Now I'm opening this empty data card data and just loading that into R. View of empty car. These are all inbuilt data sets. So here, how many rows I have? If you look at the environment section, there also you can make out. How many rows I have? 32. Observations are nothing but rows, are nothing but examples, all are same. And how many variables I have? 11. Columns, variables, dimensions, features, all are same. Different names that we use. Okay. Now, To just hover over a particular column, it gives that respective column number. Obviously, the indexing starts with 1. This MPG is the miles per gallon is the first column. Now, if I say dimensions, DIM, the short form, for some of the functions, they've used short forms as the inbuilt function. Okay, the dimensions of empty cars, 32 rows and 11 columns, right? Now, what do you think this will give me? And how many, what would be the dimensions of that matrix? 1, 2, 1, 2. What would be the dimensions of that matrix? Is it 2 by 2 or 4 by 4? Come on, think of it. 2 by 2, right? It gives a 2 by 2 matrix wherein, see, already told, whenever you're using comma in your square brackets, that follows the syntax of rows, comma, columns. So this is my rows section and this is my column section. In rows, I'm saying I want 1 and 2. That means first and second rows. In columns, I want 1 and 2. That means first and second columns. So how many values you will get overall? 4 values. Right? But instead, now what do you think this will give me? Sorry. What do you think this will give me? Line number 304. Exactly. If I leave blank, it consider all. Okay. That could be in case of rows as well as in case of columns. Gives first 2 rows of all columns. Right? Now what do you think this will give me? 306. How many values I will get? How many values I will get? 4 values, right? Clear? So what this 307 will give me? Come again. So all columns wherever, but if you observe here, gear, is this a variable or row in your data? That's a column, right? Gear, last but one. You want all the columns wherever this gear value is matching with 4. Clear? These are the criteria or condition based extraction that we perform. All these rows have got the gear value as 4. You want all the columns, that's the reason you left the column section blank. You are applying the condition on the rows. Clear? Four rows. For that, yeah, we are going to speak. We have another function for that. There are functions like head and tail. Head means use the top few rows based on whatever your selection. Tail means it gives the lower part of few rows. Now, 308, what does it give? Any row which is having the cylinder number of cylinders as either 4 or 6. Because this is a pipe symbol, this is a R symbol. Either 4 or 6. All the rows which are matching this condition will be extracted. Then what is the result? I'm not extracting the rows. I'm giving a count of it. Length of, right? Just execute the internal part of it. This gives the actual data which is matching the criteria. Or if you see the length of it, it gives the count of it. Get the column names, syntax is call names of empty cars. Now, this str is another important function for us to understand the structure of the data. Structure is nothing but it gives the data types, data type of all the columns. If you see here, all these columns are being assigned the data type of numerical. To extract the values of a single column, syntax is mtcos of mpg. mpg is the column name. But where did we get these names as well? We want only the column of MPG. But why did we get these names? Because that's not a column. They are the row names. You see here, these names are not a column. These are the row names. Generally in Excel, is to have 1, 2, 3, 4 as the sequence, right? Serial number of rows. Instead of that, we can also give a name to it. Now tell me what this gives me. 312. All rows MPG. All rows of MPG column, but you want MPG column alone, right? Clear. What would be the class of this MPG column? Numeric. I'd like to extract 3 column values together by mentioning the column names or by index. You can do that. Empty cars of C of is for combining. For mentioning the column names, mention that in the single quote. Otherwise, mention the index number. Okay. Now what this gives me? 316. We'll update whole column. Years is going to update. Years, do we have a column? Down? We don't have column called years. It creates a new column and automatically assigns the values based on the values you are providing, 1 to 32. There are 32 rows, right? Gives them the same sequence, 1, 2, 3, 4, 5, so on. View of empty cars. Now, if you see it, now the last column has been added, the years, and values have been assigned in a sequence. Clear, friends? To set null to a particular column, empty cars of years equal to null. Now, if you see empty cars years, nothing will be. Now, I'm creating 2 different variables with different values. Temp, prep, date. Now, make sure they're all of the same length. Length in the sense having the same number of values. Getting a new variable called weather. saying data dot frame of, just pass in these three variables, temp, prep, date. Now, if I say what is a class of weather, class means it gives the type, right? Then what is the class of this weather variable? Data frame, because that's already created as a data frame, right? What is the structure of weather? How many rows and how many columns? 5 rows. And how many columns? We passed in only these 3, right? Temp, prep, and day. 3 by 5 or 5 by 3? Yeah. Or else you can just see in the environment section. How many rows are there? How many columns are there? Okay. Be 5 rows, 5 observations of 3 variables. Now, to refer the columns in a particular data frame, we need to keep referring the data frame name. Other than that, what you can do is you can attach the data frame to the session, to your working session. Session in the sense, as long as your RStudio is open, till then, the data frame name goes and sits in your RAM. You don't need to repeat it every time. Okay. You can straight away refer the column names. For that, the function is attach. And I have 3 different columns: temp, prep, day. Weather $temp fetches the temperature values. Weather of 1 also fetches the same, but in a column format. Class of weather temp, class of weather of 1. There it was showing in a row format. Here it is showing in a column format. What will be the class of it? Come on, guys, just throw something. Doesn't really matter. You need to be so accurate every time. You know, there are a lot of tired faces. Is it because of too much programming today? Your eyes will get strained very fast when you start looking into something with a lot of intensity, right? They're not used to this. Slowly get used to it. Okay. What will be the data type of it? Because that shows in a data frame. Now, what does this give? Names of weather? Names. So it gives the column names. What else the names we have? The data frame, nothing, right? Gives the column names. Now, n row, number of rows. Could be caps or small as well. It works in both the cases. Okay. Number of rows, n col, number of columns, right? Small also works. Column names we already seen. Dimensions we have seen. Now, pay attention here, friends. There's another important function called describe. Describe of a data frame. But it doesn't work in R. It's a Python function. Okay. In R, to understand the basic stats about a data frame, we have a function called summary. What does summary give? What are the basic statistics, friends? Of course, we are not yet looked at other parts. Okay. The minimum value, what is the median? What is the mean? What is the maximum value? And this first quartile, second, third quartile, these are part of box plot. We will discuss next week. Okay. To get the first level of feel about how the data looks like, this summary function is really useful. By looking at the summary function, you can also identify whether there are any outliers based on the difference between your minimum value and maximum value, right? So tell me, what does this give me? 361. Values of prep, wherever it is, greater than 1. Right? How about this one? All the rows where prep is greater than 1. Difference. Very slight difference. Very useful in your pre-processing steps. Now, just passing the values randomly to a variable, and I'm creating a matrix out of it. Create a matrix, the function is matrix of the variable in which the values are stored, and define the number of rows and number of columns. So what is the dimension of this matrix which I'm going to build? 3 by 3, right? And by row equal to false. From the columns fashion, right? Now let us see what is the result. Now these are the values. First it has filled in 11. It is going in the column direction because I set by row equal to false. Clear? Once it completes filling the values in the first column, then it starts with the second column. After that, third column. But if I say by row equal to true, it goes in the column, row direction. 11, 22, 33, then 44, 55, and so on. Right? Am I clear? Now, what do you think this will give me? C of Na, comma A. No. Come out of the data frames. Simple function. C is for concatenation, we know, right? C of any value and A. A is a character. I'm passing that as a character because I'm surrounding that with the quotes. That's it. One row, two columns, right? Can I add one any value? So you do anything with any, that is still any. Okay. Cannot perform any operations on any values. Now, can I calculate the mean for a set of values where I have NA as well? Hmm? We cannot add anything to only the NA value, right? Mhm. So as per you, it's entire value should become NA. Right? But there are some inbuilt functions that are available. Especially we call them as arguments. Because there is no fun, why can't we apply a mean, though there are some NA values? Because if I load a huge data set, how would I know there are some NA values? Generally, we tend to apply some functions, right? For that, you can make use of this NA.rm. Remove NA values. It removes the NA value and applies the mean function on the remaining values. Right? Similarly, any function, sum, mean, right? Can you tell me what this line of code does? You know what is empty cars data set, right? We are applying a criteria on it. Comma all columns, row comma columns. In rows, I'm applying a criteria. And finally, I'm saying $CYL. Exactly. Right? Clear? Can you be little louder? It can. We can. We generally used to have NA values. Okay. Now, I'm declaring a variable X, passing the values from 1 to 100. What do you think this will give me? All? Sorry? That is not equal to. Right. All odd numbers should be written. Correct? For equal to, that is double equal to, comparison. For not equal to, it is exclamation followed by is equal to. And this one gives all the even numbers, right? But can I replace this part? Yeah, already it's done, right? 1 in X. Don't need to pass in the values here. And this is how we write the loops. I'm looping through a set of values, performing some action whenever it meets a criteria, right? Now, as I told, there are a lot of packages which are readily available for us so that we don't need to do that lot of repetitive work. To install a package or to load a package into R, the syntax is install.packages. Install.packages of dplayer. Dplayer is one of the basic package that's available in R. Basically used for, why do we use the dplayer? For the data manipulation. Okay. To load the data, to trim the data, to slice and dice the data. Okay. Various operations we can perform. This dependency is equal to true is not a mandatory argument. If at all you are having any issue with respect to loading a particular package, you can just add this argument as dependency is equal to true. Just execute this install.packages. It's not just good enough to install the package. You also need to load the package after installation. For loading the package into your session, the syntax is library of package name. Since already installed, I just executed straight away that library of. Friends, warnings are not something which are going to be a kind of hard stop for you. Though there are warnings, it's fine. Only and only when you get the errors, that means that's a hard blockage for you. That means you need to fix. Unless you fix it, you cannot execute something. But warnings are still fine. What kind of information that's been provided? Yes, let's take a quick 3 minutes break and we'll continue after. Online folks. right? I'm creating a variable. Now, let us look at how do we write the basic loop statements, control statements. What are control statements we are aware of? If else, for loops, while loops. Yeah. Why do we use these loops for? Yeah, for performing a criteria-based task repeatedly in a large data set, right? I'm creating a variable with random values or a series of values from 4 to 9, x. Right? What I'm saying here is, I'm looping through each of the values. I'm saying for I in x, x is the variable where I store the values. I store the values. And I is the temporary variable I loop through. Whenever the value which I'm capturing, if I divide that with 3 and the remainder is equal to 0, print this statement. Means if the number which I'm taking, if it is divisible by 3, print this statement, x is multiple of 3. Else, print is not a multiple of 3. But the syntax is important. This curly braces, we should open, close after every this loop statements, right? What is the first value? 4 is not a multiple of 3, right? And next one, 5. For 6, it's written as multiple of 3, and so on. We have this empty cars data set, right? For I in 1 to 32, if the number of gears of a record is matching with 4, then replace that with 7. If it is 5, replace that with 8. If it is exactly 3, change it to 6. Right? If you look at the current data, we have 4 and 5, 4, 5, and 6 for the gear values. 3, 4, 5, 6. Sorry, 3, 4, and 5. We're replacing that with 6, 7, and 8. Whenever you are executing this control statement, you need to execute the complete block. Clear? Now, if I see, let me show you only empty cars of gear. You are seeing the values only 6, 7, and 8. Right? It's been replaced. This I is the temporary variable, friends. Empty cars of gear I is nothing but we are iterating through the number of rows here. We are taking the first row. In the first row, the gear number is matching with 4, perform this. Clear? Now, there's another important function in R that's called table. This empty cars of gear is giving me what are the values of the gear, right? 6, 7, and 8 for each of the records. But if you would like to see how many records are there with the gear value as 6, with the gear value as 7 and 8, the proportion it gives. It's very important for us to understand the proportions. 6, there are 15 rows. That's what table does. 7, we have 12 rows. Right? We're going to use this very frequently when we start building the models for classification problems, including logistic regression. Now, while loop, we need to initially assign a value, right? And then till this condition holds true, it keeps executing. Whenever this condition fails, it comes out of the loop, right? One is equal to 1, I is equal to 1. While I less than 32, that means till the point the I value is less than 32, we keep iterating through. Take the first record and print the cylinder number and iterate, increment it. I is equal to I plus 1. Next, it becomes 2. Print the cylinder value for the second record. Again, increment it. 3, right? Till 31, it prints. Whenever the row number is 32, it's going to exit. Clear? Now, other than this, there are some very efficient, of course, for writing the if-else code, if-else statements, you would need to follow all this syntax. But in spite of this, if you're working with a simple calculations, so simple criteria, if else, you are mentioning a condition. Is 1 is greater than 3? One is greater than 3? No, right? What does it give if I just execute this part of the code? 1 greater than 3? False. Right? If else 1 is greater than 3, comma 1 comma 2 I'm giving. Means if the condition is true, print this value, the first value. The condition is false, print the second value. If the condition is false, printing, right? And similarly, let's look at the proportion of the gear values from empty cast data set. 15 rows are there for gear value 6, 12 for 7, 5 for 8. Now, if the gear value is 3 comma, if gear value is 3, print it as 6. If it is not 3, make it as 8. Using the if-else function. Now I'm again updating empty car's gear value with the outcome of this expression. Clear? So effectively, you're already saying, do you have any records with the gear value as 3 right now? You're seeing here, right? There are no records. Effectively, what should be the value after executing this line of code? All the records gear value will become 8 because this condition is not meeting. Now, if you see the proportion, all 32 records gear value will become 8. Clear? Now, there are some basic functions that we need to be aware of. Now, let's try to understand how do we load the data into R. Provided you're given some Excels or CSV files. How do you load the data? Because XLS has got some limitations with respect to the data it can hold. And also it keeps hanging as and when you start increasing the more, pumping down more and more volumes of the data. But CSV can hold any volume of the data. Okay. Most of the times, if you're not extracting the data directly from a database, connecting to a database, or if you are interacting with the data engineering teams for whom you are going to give a requirement, okay, what is the format, what are the column names, of how exactly you need the data. They're going to extract from the source and store that in the CSV formats, share the location to you so that you can start working with those data, right? For importing the data into R, there are multiple ways. One is through UI based. UI in the sense, under the environment section, you're seeing this drop down, right? Import data set. There are different options available. The first one is from text. Within the braces, you have base. Means if you have the notepads, TXT files, some tab delimited values, space delimited values, comma delimited values, you can still load through text using this option. From text reader, this is the option we use to load CSV files. And this is purely from UI. Most of the time, we are not going to use UI. We'll be using the lines of code I'm going to show you afterwards. Let me try to load a CSV file. The moment I click from read, what is that option? Reader. Just a second. From text reader, what happened? What is not available? Oh, that's fine. Don't worry for now. Okay. Just need to do install.packages of reader. This read R, what you are seeing here. It will install, then enable that through library of. Then you will be able to see it. So through the UI, I can just browse to the location of the file. CSV file, yes. So I'm just loading this MBA data set. So it shows the preview as well. What all the columns I have. Just give me a second, friends. Sorry. Sorry for that, friends. So once we load this, here under the import options, you are seeing the name, right? And this is the name of the variable by which it will be stored in R. This will be the variable name. If you want, you can update this name to whatever you want. If you prefer to import the data through this option. And you see here, skip. If your file is in a format where you need to skip first 5 rows or 10 rows, you would like to load the remaining, there you can mention the number of rows by which it can skip. And this checkbox for first row as names will be checked by default. The first row, it will take as a header, names of the columns, the names of the variables. That's not the case, you need to uncheck it, or update it accordingly. And it's a comma delimiter, CSV file. And in the background, it's going to execute these 3 lines of code. It's going to load the package called readr. And read underscore CSV is the function it's going to use to load the CSV file. And this is the full path from where I selected this CSV file. Okay. And finally, it opens the data set for us to view. Let me just import it. The data set is imported. If you see the environment section, this MBA, that's the name of the variable, or the variable name under which this data is saved. Number of rows, 773, and columns, 3. Okay. Clear? This is one of the options to load the data, but we really don't prefer this. We generally go with this. You can just, sorry. Who will actually spend 2 minutes of time in navigating through all these files and everything? Same thing we can do in simple by executing a simple line of code. It's all efficiency. Okay. So if you choose here, this file.choose does the same thing. Only thing is, it will also open the prompt for you. You can choose the file. Otherwise, read.csv of mention the complete path within the quotes. And you need to be mindful about, let's say I'm loading this data set. So by default, if I take the path, relative path of any location, you'll have this backslashes, right? Backslashes will not be accepted either by R or Python. Either you can do double backslash or single forward slash. Okay. Both of this work, right? Now the X variable has been created with same 773 rows and 3 variables, right? Mostly we work with CSVs. Otherwise, we connect to the database and extract the data, but mindful about whenever you are establishing a connection with the database. R or Python are not the database. They're just the softwares for performing the analysis. They cannot accommodate huge volumes of data. So when you are actually extracting the data by by establishing a connection to the database, you make sure the volume what you are extracting is sizable enough with respect to the infrastructure what you have. It purely depends on your RAM, CPU process, right? Unless and until you have a huge infrastructure, very latest one, don't go for that option. Okay. Okay, fine. So let us see some user-defined functions. Function of n is pretty much readable, right? Pretty much understandable. So if the number is divisible by 3 or not, I'd like to write a function, custom function. Writing the custom functions is very important. Let's practice it. Doesn't take much time. As part of the pre-processing, writing these custom functions and slicing and dicing the data and applying criteria-based filtering in your data. These are the major things what you're going to do. Okay. Applying this on this data, Z is divisible by 3 of Z. The number is not divisible by 3. Which number? We are not set to increment. It's taking only the first number. Wait a minute. Okay, fine. Now I'm writing a custom function to extract the basic statistics about any data that we load. Syntax doesn't change. Function of the stat results. I'm initially setting these m name, mean of the data frame, median of the data frame to null. Okay. Later on, I'm iterating through each of the columns. I'm extracting the names, mean, median, and everything. And finally, I'm updating the stats results with the value what I'm going to get. Let me just execute, then I'll explain. Now, I'm taking from the empty cars data, I'm taking what two columns, two rows, which is 1 and 3, and two columns, which is 9th and 11th, into a separate variable. Now, number of columns, I have to, sorry, number of columns of empty class. Oh, this is T of first column, all rows, first column, 3 to 9, right? 3 to 9, how many columns we have? 6. 7, right? In fact, 7. 7, 8, 9. Overall 9 columns we're getting. So I'm applying this custom function, whatever you just seen on the empty cars. This M name, we're capturing the variable name. For each variable, what is the mean value? What is the median value? That's what we have done. But how exactly that was done? For I in 1 to n call. N call is what? Number of columns. We are first reading the number of columns. We are iterating through that number of times, the for loop. While we iterate through, let's say we are talking about the first column. I is equal to 1. So we are taking the column name of first. What is the column name of the first? I think it is MPZ, right? Now we have extracted MPZ and send it to the M name of stat results. Then we are actually extracting the mean of it and send it to stat results. Median, send it to stat results. Next, we are taking I as 2. We keep repeating to the number of variables. And finally, we will have all these values captured. Sorry. Only for the selected columns, we managed to capture the selected, the mean values as well as median values. Okay. Yeah, guys. Most of the other things we've already seen, basics of R programming. But we have another 15 minutes, right? Yeah, let me show you some string related operations so that if at all you have to work on unstructured data, that will be useful. This is a comma separated txt file, right? That's having a lot of junk characters as well. So using the function read lines, I'm loading that victim function, text file. You see the environment section. You can see that the character data type has been assigned to it. There are 11 lines. We are reading by line by line. See the class of it should be character. The victims, yeah. There are 11 lines. Each line has been captured separately. What kind of operations we can perform on this kind of data? Victims of 4, to capture the fourth line, converting it to a data frame. Now, if you see, that's the data frame. Sorry. Number of rows. This grepl is a very useful function when you work in regular expression. Character. grepl of, we have some 10 characters as well, right? Cap percentile, comma, I'm applying this on the victims data. The variable victims, whatever the data I have stored, I'm applying on that. Comments. Now, if you see on the comment, wherever this percentile is there, and this is our original data, right? Wherever the percentile is there, it returns true for that line. Otherwise, it returns false. Now, to understand the actual functionality of grepl, percentile C of AB, A percentile B. What should it return? First one, there is no percentile, it returned false. The second one, there is a percentile, it returned true. Now, grepl, what should it return now? False, true, true. Is that what it's going to return? It excludes the last character. If that percentile exists in the last character, it doesn't consider. Okay. And cap A. Now, what should it return now? We are searching for A out of all these three. Why it is returned false? For the last one. So whenever we are using grepl, whichever starts with that particular character, what we are searching, only that number of instances it returns as true. Though that character exists somewhere in the middle or towards the last, it doesn't consider. Now, we are changing the pattern. Till now, we are saying cap A. Here, we are saying B dollar. Any of them are ending with the character B. If you mention the special characters, after that character, it looks for whether the relevant strings are ending with that letter or not. Any of them are ending with C? True, true. And this is false. Clear? And if you just use grep, the same data, how do you think it is returning integer of 0? Number of times it is true. And the sub function is also very important. Sub of ABC, comma DEF, in ABC DEF. How it works is, sub of ABC, what it works is, if A is found in C, replace that part with the B. If ABC is found in the last one, is there, right? ABC is there. This ABC will be replaced with the value of B. So finally, our result will become DEF, DEF. Right? And if 2, 3, 4, 5 is found in this, that will be replaced with blank. Okay. Regular expression. Regular expression gives the position of the first occurrence of the value you are looking for. First character is a blank, second, third, fourth, fifth. Right? In the fifth location or fifth position, your 9 is there. That's why it is returning as 5. Regular expression of 9, comma, C of these two texts. That means you are concatenating these two texts and looking for whether 9 existing or not. Five comma 14. This first looks at this. In the fifth position, it has already found 9. In the second text, in which position you have the 9, the first occurrence of it. I think this should be fine, guys. I don't want to strain too much. It should be fine for you as part of the basics. But tomorrow we'll look into the Python, basics of Python. And alongside of this, we'll also look into the basics of few graphical representation. Histogram, bar plot. Yeah. Online folks, any questions before we wind up with respect to basics of our program? Any questions from classroom? Is it open? Okay, guys, thanks for attending. We'll meet again tomorrow at 2 p.m.